Most of what we're going to do for the rest of this quarter involves using integrals in application settings. So we'll be setting up integrals and then evaluating them to figure out things like volume or area or work done or all sorts of different things. Almost every problem involves evaluating a definite integral. And it turns out that your calculator, if you got one of the standard graphing calculators, Texas Instrument, Casio, any of these, Hewlett-Packard, um, they can do definite integrals. Some of them can do indefinite integrals as well. They actually take antiderivatives algebraically. But even the ones that don't do that will do definite integrals. So for instance, say I want to integrate um, x squared from 0 to 3. Right? So I've got my calculator here. I'm going to press on the math button and go down. Actually, I would go up, but I'm going to go down to number 9. Number 9 on this calculator is function int. So I'm going to select that. I'm going to say what function I want to do. So x squared. I have to say, essentially this is the dx. So I say x squared and then I tell it what my variable is. My variable is x, comma, and now the limits of integration. I'm going to go from 0, comma, 3. So that's the syntax, the function that you're integrating, the variable, so essentially the dx, lower limit, upper limit, and then I hit enter, and it gives me a value, 9. Actually, if you think about it, x, that would be x cubed over 3, plug the 3 in, plug the 0, well the x cubed over 3 would be 27 over 3 is 9, you plug the 0 in, that'll be 9, so indeed it did calculate the definite integral. Now it's doing something like Simpson's rule, the trapezoid rule, or something like that. It's not doing either, it's doing something related to those. But it's coming up with a pretty good approximation of the integral. Okay. If you want to do just one more example here, let's do math. I always go up because up wraps around, so it gets me to the 9 faster there. Function int, let's do the sine of x. If ever I'm doing calculus with a trig function, I better make sure, I'm just going to double check here, that I am in radian mode. Yes, I am in radian mode. So, all right, let's come back. So sine of x, comma, x, comma, let's just do one bump of the sine curve. Let's go from 0 to pi. I think we've done this integral several times. We know that the value should be 2. And it calculates as 2. Okay. So anyway, I am not going to be so interested in seeing you do all these integrals by hand for the second half of the quarter. I am much more interested in seeing how you set them up, and then you can use your calculator to evaluate them. That being said, if you do them by hand from time to time just to stay in practice, that's probably a good thing. But anyway, I want to make sure you know how to use your calculator.